Okay, so there are some interesting radical problems that we're going to take a look at. The first one is a problem that looks like this. And so you're asked to simplify the square root of 9 plus 2 root 14 plus the square root of 9 minus 2 root 14. And we're going to use a technique that essentially assigns a value, a variable value to what we want to find, and then see if we can do some algebraic manipulation to get it in a better form than having what's referred to here as a nested radical, which is a radical inside a radical. So to do that, we're going to say, well, we know this has to equal x. Now we've got an equation and we can apply equation properties. And we're trying to find out what does x equal. And the technique to use here is whenever you have a radical equation, which is what this is now, is to square both sides. Okay, and so the right side is very simply just going to be x squared. And so the left side here, we got to think about what we're squaring. Well, this is just like a binomial, right? And remember, if you have, a plus b squared, that equals the first term squared plus 2 times the product of the two plus the last term squared. So the first term squared is just going to be this whole thing squared. Well, the square of a radical is just what's inside the radical, so 9 plus 2 root 14. And then it's going to be 2 times, well, it's going to be this times that. Well, when you multiply those together, what you're really going to end up doing, so like if I have radical A times radical B, that just equals radical AB. And so it's going to be the square root of 9 plus 2 root 14 times 9 minus 2 root 14. And then it's going to be the last one squared, which will give you 9 minus 2 root 14, because you just got a radical and you're squaring it. All right, first off, notice the good thing that happened here, which is one of the reasons why we're doing this, is the 2 root 14 and the negative 2 root 14 canceled out. So that gives me 18. And then inside the radical, I have this binomial, but this binomial represents difference of squares, right? Because you have a plus b, a minus b. So what you're going to have is 81 minus 2 root 14 times 2 root 14, which equals 4 times 14, which is the same as 56. Recognize that negative 18 root 14, positive 18 root 14 is just going to cancel out. And so that gets me x squared. The radical 81 minus 56 is the same as square root of 25. Square root of 25 is 5. And so you end up with 18 times 2 times 5 equals x squared. And so that gives you 28 equals x squared. So when we squared this, what we actually came up with is 28. We don't want to know what x squared equals. We want to know what x equals. So we're going to finish the problem by taking the square root of both sides, which gives us 2 root 7. So now what we've done is we've taken this complicated thing and recognized, wait a second, it's equivalent to this much less complicated thing. To verify that we're correct, we can type it into a calculator. And so when we take a look at this calculator here, you can see I've got 9 plus 2 root 14 times 9 minus 2 root 14, and the answer just turns out to be 5.2915026. And so if we wanted to compare that, well, what do we compare it to? The square root of 28 or 2 root 7. It depends whichever one you want to put in there. And that equals 5.291502622. All right, so let's try one more of those. And so another example of this would be one like this. The square root of 11 minus 4 root 6 plus the square root of 11 plus 4 root 6. We want to simplify this, and so one of the tools that we have at our disposal is to square both sides. And so when we square both sides on this one, we get the first term squared, which is 11 minus 4 root 6, plus 2 times the product of those, and so 11 minus 4 root 6 times 11 plus 4 root 6, and then plus 11 plus 4 root 6 equals x squared. These cancel out, so you get 22 plus 2 times the square root of, and so that's again going to give you 121 minus 4 root 6 times 4 root 6 is 16 times 6, which is 96. And that's going to equal x squared. Well, that also equals 25, like in the last problem. it's not always like that. It just turned out to be the 2 for the ones I chose here. So that's going to give me square root of 25, which is 5. And so you're going to get 22 plus 2 times 5 equals x squared. So x equals, so 32 equals x squared. And so take the square root of both sides, and you get 4 root 2. And so you get this complicated double radical, nested radicals, do some manipulation on it, some algebra that we've learned, and we end up with x equals 4 times the square root of 2.